so that you guys can have a copy of it. Okay. I think everyone is back. So let's go ahead and go. So we're looking at the mother and daughter heights, and we're going to use that data in StatCrunch. So here is our data, mother and daughter heights, and we want to calculate the linear regression. So we'll do stat and regression, simple linear. Our X variable is our predictor variable, which is mother, and our Y variable is our daughter, because we think the mother height may predict the daughter height. For now, we just ignore everything here and click compute. I'm going to make this big because this is what we need to see. So we have our variables, we have our line equation, our sample size, our correlation coefficient, and our R squared. So I'm going to go down back to my question sheet, which says determine the correlation coefficient and describe the strength and direction and compare it to the critical value to determine if there's a correlation. So going back to my StatCrunch output, my correlation coefficient is here. I'm going to copy that. And this is negative and weak correlation. So the question is it too weak to be considered correlation? And that's when you go to the critical values. So if I go to the critical values chart, which I don't see, hold on.
It's 0.404.
Yeah, I'm going to show it anyway, thanks. Okay, let's make that a little bit bigger. So our sample size was 24. So our correlation we're comparing it to in our critical value chart was 0.404. So because 0.255 is less than 0.404, we have no correlation. Okay, next question. Insert a copy of the scatter plot. So if I go back to StatCrunch, where this button is, I go right, and I can get a copy of the correlation of the scatter plot with the fitted line. So I can do options, copy, and then right-click the image to copy it. Or if you need to save as a picture and then insert the picture, you can do that depending on your computer. So then going back to my Word file. Oops. I have it there. Okay. Determine the equation of the least squared regression line. So going back to StatCrunch. My least squared regression line is the line that starts with the X variable daughter, or the Y variable daughter. So I copy that and go back to 'and paste that. So the slope and the intercept, you can get it from this equation, but also if you look in StatCrunch, the slope and the intercept are given right here. So there's no reason to get those incorrect. Right? So the slope is equal to negative 0. I'll round it to 0.089. And the y-intercept is equal to 62.605. I'm going to do them separately so you can see to interpret, so I have enough room. So as the x variable, which is the mother's height, increases by 1, and it's always increases by 1, then the daughter's height decreases by 0.089. And these are both inches, so I can go back and put inches for both of them. So literally one mother doesn't increase her height, but as we go from one mother's height to the next, which is up 1 inch, then we expect the next daughter's height to decrease by 0.089 inches. Our y-intercept is 62.605. So that means our x variable is equal to 0. So when the mother's height is equal to 0, we expect the daughter's height to be equal to 62.605, which is not a part of this model. It doesn't make sense, number one, to have the mother's height 0. And in fact, if you look at the height, 0 is way outside of the values that were given for mother's heights. Oh, that goes here. So I can copy and paste that down here. That goes down here. Okay. So predict the height of a daughter of a woman who's 57.5 inches tall. I'm going to go up and grab that line equation and use it down here. Oops, get the whole thing. And that's what this line is good for predicting. So we put it here, and instead of mother, we're going to substitute the number 57.5. Now, to make it simpler, I'm going to round these numbers to 0.089. Oh, get rid of that. And 0.605. Makes it easier. So I multiply 0.089 times 57.5 and get this equal to 62.605 minus 5.1175. So when I subtract that, I get 56.933.
Professor, did you say 62.05 or 62.605?
Oh, 605. Thank you. I did that wrong. Thank you. So let me recalculate it. So 62.605, thank you for that, minus 5.1175. And that will be 57.488. So now to determine the residual for the mother-daughter pair found in line 13, which I put here for you to make it easier, we remember the residual is equal to the observed y minus the predicted y. And I have that memorized because I've been teaching stats a long time, but the way I first memorized them is that O and P has to be in alphabetical order, observed before predicted. Then I didn't mess up. So the observed y is equal to 57.7. That's given to you as the daughter's height, minus the predicted y. So I'm going to go down here and find the predicted y. Using the equation. So daughter is equal to 62.605 minus 0.089 times the 59 for the mother's height. Oh, that should be an equal to. So I have 0.089 times 59. And I'm going to subtract that from 62.605. Oh, that's wrong. I did something wrong. 0.089 times 59. And subtract that from 62.605. I get 57.354. And now I'm going to put that into this equation up here. So this is 57.7 minus 57.354. So I get 0.646. Pretty close. So, and the last thing is the coefficient of determination, which is our r squared. And you could just write the word r squared as like it's one thing. It's fine. So I'm going to go back to StatCrunch. And my r squared is right at the bottom, below the correlation coefficient, r squared here. So I'm going to cut and paste that. And go back to Word. So r squared is 0.065. And that means 6.5% of the deviation in the daughter's height is determined by the correlation, or sorry, the regression equation. Which is, oh, I spelled that wrong. Which is why it's not a good, it's only 6% of the deviation. So that's why it's not a good model for regression. All right, so I'll be making that movie and posting it as soon as I can today for you guys to have.
I think the receipt